Okay, so inverses graphically. Does anybody remember how inverses are related graphically? Now you had a couple graph examples on the back of this to look at. Anyone remember how you could find them? Yeah? Yes. Okay, so inverses are reflected okay, they're reflected over y equals x. It's a diagonal line. Okay. The graph is not going to be very big, just a couple points, like maybe count by threes. Okay. So if I have the point two, 1, I'm just going to dot my diagonal line here. Okay. That's the original point. I'll call it, well, I was going to call it y. That might be, call it f. Okay. Just call the point f. Give it a name. And I want f inverse. Graphically, not algebraic, right? There's no equation. So how would I do it graphically? Well, sometimes reflecting, depends upon how visual you are. You can reflect that over the line. It's like taking this and folding it over. But sometimes it's kind of hard on a diagonal. It's okay to like reflect over a straight line, but a diagonal, a little bit tricky. So how can I find the inverse?
You just swap the y to the x.
Yes. Switch x and y. That's kind of the key statement between inverses. It's not a very technical definition, but it's very easy to work with. So I would switch x and y. 1, 2. I'll do it in green. 1, 2. This would be the point f inverse. That's it. You switch x and y. Plot the points. On your worksheet, I saw a lot of people writing equations and trying to do it algebraically, but you could have switched the points and then tried to draw it. But both methods work. Sometimes algebraically is easy, sometimes just switching the points is easy. You had the graphs to look at. So for example, question number 11, I'm looking at my graph. I'm like, well, it kind of looks like a square root graph, but I don't really recognize that transformation. Well, it's because it's a transformation we don't talk about. But if I take my points, 4, 0, 3, 1, and 0, 2, A, B, C. Order is important, right? I want to switch them and draw them in the same order. Okay, this is the end point, and we're going this direction, and then I'm going to have the arrow. So I switch them for the inverse, 0, 4. That's the end point. 1, 3, 2, 0. That's the arrow. Okay, and I look for it. Who's got a 0, 4? Okay, 0, 4. 1, 3, 2, 0. Look at the arrow. End point to arrow. And that's how you can find your inverse. Right? You don't have to do it algebraically. Okay. Okay. So all points are switched. X comma y turns into y comma x. This would be the original. This would be the inverse. Leave a bullet here. Okay, we're going to write a sentence. Then we're going to write a big sentence. It'll fit on one line. Okay? And we're going to do an example. I'm going to keep it really simple to start. Square root x plus 3 okay, find the inverse. That's what I want. Let's do it algebraically. Then let's do it graphically. Okay? Algebraically. And then we'll do it graphically over here. Okay. Switch. Square. Okay. Subtract. See how this is called f of x? I'm going to switch to my inverse notation. Okay. Should be okay here. Let's try to graph. Yes. Keep it in a format that you can graph it in. So you could expand it, except that that's in vertex form. It's a lot easier to graph in vertex form. So I would leave it here. Yeah.
So because we do PEMDAS inverse, would you subtract 4 first?
I did.
Oh.
Yeah.
Okay, yeah.
It's fine. Okay. So let's sketch a little graph here. We should only need quadrants 1 and 2, I think. Maybe 4. Okay. I really just need the endpoints and the arrows in the right place. I'm not so picky about the rest of the points for this particular graph. Okay? Just the endpoint and the general shape is what I'm going for. So the first one is left 3. 1, 2, 3, 4. Okay, here, right there's my endpoint. 3, 4. And the graph is opening to the right. So over 1, up 1, 2, 3, 4, up 2. Okay, just the general shape is what I'm going for. Endpoint and arrow. Okay, well, graphically, draw the inverse. Right? Don't look at this. Graphically, just draw the inverse on the same grid. I don't care what the equation is. I want you to do it graphically. Maybe, right? I have a hard time reflecting over a diagonal, so I just write down a few of the points that I'm trying to switch. Okay. right? I got endpoint, arrow. It seems silly, but you're going to want to keep track of which points go where. Huh. Okay. I mean, I practiced drawing my graphs, so mine looks really pretty good here. Mostly to scale. Yes.
Why did you get inverse of points?
Okay, that's the question for today. Okay? And that's what we're going to talk about. This and my graph don't match. They don't match. But if I look at this graphically, I'm like, yeah, blue and green look like inverses. I just switched the points and I did it. But why didn't it work algebraically? Because this is a graph of a whole parabola. That's a whole parabola. There's no stopping point in the middle. So what happened? When you have a square root graph to start with, let's jot down our domain and range of our starting graph. Okay, I've got the blue picture here. So let's do our domain and range. 1, 2, 3. So my endpoint, right? The x-coordinate is -3, and it goes on to positive infinity, right? Start, stop. Okay, now my range starts at 4 and it's going up. So my range is 4 to positive infinity. And I'll switch colors. We'll do it in green. Looking at the graph, can you just tell me what the domain and range is of the green graph? Don't look at my equation. I don't care what the equation is. I want to know, just looking at the graph, what should the domain and range be? 1, 2, 3, 4. I'm just going to label my point here. Makes it a little easier to see. Okay, who can give me domain of the green graph? Yeah, Gray.
Domain, so that's going to be 4 infinity, and then
Yep.
range is -3 infinity.
Yes.
Positive infinity.
Yeah. Look what happened. I switched. Everything for x's and y's will switch on an inverse. If the original domain describes x's, then it's going to describe the y's on the inverse. If the range of the original describes y's, then it will switch and describe the x's. It's called a restricted domain because algebraically you got too much of an answer, right? You got too much. This is a whole parabola. I only wanted half a parabola. You have to figure out which half. How do you figure out which half? You look at the picture. Okay? So this is a restricted. I don't think I spelled that right. Restricted. Is there a T in there? Restricted. I don't know. Give it. Yeah. There you go. Okay? You have to give me the restricted domain. Notice that I was not looking at the equation when I gave the domain. I was looking at the graph when I did it. Okay? Notice that it does correspond to where the vertex would be. Look at that. 4, -3. It does correspond to the vertex, but I needed to pick the right half of this graph. Okay, so now we're going to fill out those 2 blanks that we left up here. Okay? And we're going to say inverses will always match the original. Okay? The original graph, that's the graph that's important. That's the one that's going to answer your domain and your range questions. Okay? It's not the algebraic equation you come up with. It's the original graph or the original equation that's going to determine what kind of domain and range you need in the end. Okay, and then for the last bullet up here, we are saying how the points will switch. Domain and range switches also. Domain and range switches also. Right? Everything about x's and y's will switch. Everything. Find the inverse. Okay, find the inverse given g of x equals 4x minus 2 squared plus 3. Okay, so this time I put a stretch value there. So a few more steps to finding the inverse. We're going to do it algebraically, right? A little bit of review. And then I also want you to sketch it graphically, okay? The endpoint or the vertex and the arrows, those are the things you really got to be careful with. And you should only need quadrant 1 for your graph. Okay, there you go. 6 by 6 should be big enough. Not F. It should be G.
What's going on over there? Is Greg having fun? Stop him.
I'm out of whiteout. There you go. G. Okay. So green is for the inverse. And blue is for the original. You can start on either place. You want to do it graphically first, do it graphically first. Do algebraic first, do algebraic. So that comes out.
So then, g of x equals and then
X minus 3 plus 2. So it's in think AHK. Right? You want it in that kind of format.
I know this.
That's fine. We'll put it 1/2 in front of the radical. You guys have the same inverse, try to write it in a format that has A, H, and K. So that you really end up with this. And then it's like, oh, okay, that's just that A value.
No, it's NHK.
It's the exact same thing.
Excuse me, sir. What is this?
Do your work. After head the first point. Yeah, I'm talking to you.
How do I return to my base? I don't have to
But let's write it with a 1/2 root x minus 3. Right?
kickstart my rocket ship.
All right, let's do a little bit. Any preference? What do you want to do first? Algebra? Yeah, okay, we'll do algebra first. Okay, notice I changed the letter. The letter is just the name of the function. Okay, so I'm going to switch. Okay, you are looking for A, H, and K when you are solving for Y. So I'm going to minus 3. Now, there's a few choices here. Do you notice that everything on the right side is a perfect square? Right? 4 and this square. They're both perfect squares. Now, most of you probably divided by 4 first. So I'm going to do that. But I'm not going to distribute. I'm thinking about A, H, and K. And so I don't want to mess up my groupings, right? The x minus 3, that's a transformation. So I don't want to distribute yet. I want to finish solving before I decide what to do. Then I'm going to square root. Okay, you have any perfect squares right here? Yeah, the 4. So you're going to get root x minus 3 over 2. It's a perfect square. Okay, equals y minus 2. Okay, and then I would add 2 over, and that would give me the inverse. Now, fractions. Guys, that 2, divide by 2 is the same thing as multiply by 1/2. And then root x minus 3 plus 2. I'm trying to keep it in the A, H, and K format, which means divide by 2. I'd rather write it as times 1/2. Okay, and graphically, write 2 and up 3, and that graph is really skinny because of the 4, so it's over 1, up 4. Okay, there's my starting point, and I'll just jot it down. That's a 2, 3. Right? That's the original. Okay, so I'm going to write down my domain and range of the original because everything has to come back to the starting point. Range is, okay, and inverse. Well, I already have one graph. I could just swap my points and draw the inverse. I could also try to graph the radical. It doesn't matter, guys. It doesn't matter how you get the graph. Whether you go from the original graph to the inverse graph, or you go equation, inverse graph. It's a big circle. You can start wherever you want. Okay? So this is right 3 up 2. Okay, that seems reasonable. My vertex or my starting point is switched. And this graph says over 1, up 1/2, over 1, 2, 3, 4, up 1. 1. That makes sense. Okay, that works. something doesn't seem right because the pictures don't match. Sure, there's a mistake. Where's the mistake?
In the parabola?
Nope. You cannot change where you start. This cannot change. You cannot change the original. I didn't do plus or minus. What happens when you do a square root to solve? You get plus or minus. You get plus or minus. I don't care that it's inverses. We are solving for y. Oh, so I've got the top half of the radic of the square root graph, and I have the bottom half. I got the plus and the minus here. I've got the plus and the minus. The plus and the minus. So when I'm graphing this, I'm really graphing this. I'm graphing the positive 1/2 stretch, but I'm also graphing the negative 1/2 stretch. But look at the picture. They don't match. See as how I have to start with the blue. Okay, I got this part. I need this part. It has to match the starting point. Has to. And so, look. The domain and range switch from the blue. I'm not switching the green. I'm switching the blue. Blue is where you started. Everything has to match the blue graph, the blue equation, the blue domain and range. The only thing you're allowed to adjust is the inverse. Yeah, we don't usually write equations with pluses or minuses, but I need it to make sure that the green graph is actually going to match the blue graph.
How did you find the original graph? Like graph it out?
Okay, so it's a parabola parent function. So I'm thinking this, and my points for a parabola are 0, 0, 1, 1, 2, 4. So right 2 up 3, and I stretched by 4.
Oh, okay.
Yeah?
Yeah.
Yeah. A different example. Okay. Yeah, we actually haven't given you the definition of an inverse yet, right? I told you how to find it, and I showed you how to graph it, and I showed you how to solve. But the definition of an inverse is this. F composed of F inverse. That's actually the definition of inverses. So when you compose them, you get X. Now, this composition should work in either format, right? Whether the F is on the outside or the F inverse is on the outside. That is the definition of inverse. That doesn't really tell me how to find inverses. It doesn't really tell me how to graph inverses. It doesn't really tell me how the domain and range are related. Okay, but that's the definition of inverses. Okay. So, example 3. Okay. Using g of x, okay? It's the same one that's above here, okay? And g inverse of x. But I'm going to change it slightly. Just put 1/2, don't put plus or minus. we typically only work with functions, okay? Notice how that green one up here wasn't a function. And so in order to do this example, I'm going to restrict the original. I'm allowed to start the prompt any way I want. And so I'm going to say g of x, I'm just going to give you the domain. I'm going to give you the domain I want you to work with. Domain, and okay, notice that my vertex is at 2. And so I'm going to give you, that's the right half of the parabola, right? I went to the vertex, and I went to the right. That's the only part of this graph I want you to deal with. That's it. Okay, so they are inverses. How do I know? Because I labeled them that way. I told you G and G inverse. That means they are inverses. Okay, find G composed of G inverse of 4. Okay, so I know it's been a little while for our composition. It's just start on the inside, okay? Just start on the inside and find out what G inverse of 4 is. That means plug in 4. Okay? Just start on the inside and work your way out. Yes. Okay, so I get plus 2. So I get 1/2 root 1 plus 2, 1/2 plus 2. Okay, so I get 5 halves. 5 halves, does that seem right? Yeah, okay. So I get 5 halves. Go with the improper fraction, not a mixed number. So we got 5 halves. Okay, but that was only like the very inside, right? Now I have to do G of 5 halves. Okay, all I did was this inside part. I still have to do G of 5 halves. So now go plug it into G. Okay, G of 5 halves. Okay, I'll give you a little minute to... It's just basically you plug in twice, right? You start on the inside and you plug in 4. You get your result. Then you plug the result into G. Composition is just substitution. Okay? See what you get. I mean, I already know the answer, but see what you come up with. Yeah. Mind blown.
Can you do that for any number though?
Yes.
Oh, no.
So if you wait till next year. Should be, by definition. 4. Should get 4. You're almost there. Should get 4. Okay.
Oh, I got 4.
Yeah, okay, let's look. All right. So this is 1/2 squared plus 3. Because 5 halves minus 2 is 1/2 squared. So you get 4 times 1/4 plus 3. So that's 1 plus 3 is 4. Hey guys, I just told you the definition of inverses. You actually didn't need to do any work to answer that question. Look at the definition. If you have inverses and you plug in x, you'll get x. That's what that definition means. Right? That's what it means. Whatever number you plug into the composition of inverses, you're going to get that number out. And so we just did it algebraically. Okay? Now we're going to do it with a more general expression. Okay? More general expression. This is called, I know you can't see it. Verify f of x and g of x are inverses by using the definition of inverses. Notice switching in x and y, showing graphically, that is not the definition of inverses. That's just examples of how it works. And so when I say verify f and g are inverses by the definition, I mean the composition. Okay? That's what I mean when I say those words. Okay, so I'm going to just write down the definition. Okay? Definition. If f and g are inverses, that is true. And, right, both directions. Now, I've never seen it work one way and not the other, but it is good practice on your simplifying in order to do both. Okay? So here we go. Given example 4. This is our last example. F of x equals 2 root x plus 2 minus 3. Okay, so I've got A, H, and K. Okay, and I'm going to give you G. 1/4 x plus 3 squared minus 2. But I'm going to need to restrict that domain, because otherwise they're not a match. I can't tell you something is inverses without the proper domain and range for both of them. And so take a minute to think about what should your domain be for G. All right, because I can't even do this problem unless, well, if I want the answer to be yes, I can't do this problem unless they're actually inverses. The answer is supposed to be yes. Okay, so what should my domain be? 1, 2, wait for 3 more people. 4, okay, Michaela, what is it?
Positive 3 to positive infinity. Oh, yeah, it should be negative.
Yes, negative 3. Okay, somebody else tell me where you get it from. Yeah.
You take the original points and like -2, -3, and just inverse them.
Yeah, you do. Okay, so you can do a quick sketch, guys. Left 2, down 3. Right, I could do a quick sketch and like flip it to figure out what the domain should be. Okay, also, look at this. What's the range of that graph? Yeah, the range turns into the domain. The range turns into the domain. Okay, so let's set it up. Let's do the first part. F of g of x. F is on the outside. G is on the inside. Oh. Yeah, I'm doing the colors on purpose. It makes it a little easier to tell where that substitution occurred. Yeah, I could put parentheses here for what I plugged in. All right, yeah, give it a shot. Yeah. Yeah, the hard part here is not the setup. It's actually doing your order of operations correctly. So you're simplifying PEMDAS. Work your way all the way from P to S. And start back over again if you have to. Right? Simplify the parentheses first. Now that's a square root. If you see a perfect square, maybe don't touch it quite yet. See what you think. Without me showing you the easy way to do it. Okay, if you've got pluses under the radical, you can't simplify. You can only take out multiplied. As you are supposed to be getting x. Right? The answer is yes. Okay?
How do we tell if the answer is yes? Well,
If you get x as a result.
okay.
Right? Now, could you like test yourself and try a number to see if a number worked because you're better at doing numbers? Sure. But it has to work with just the x's. Okay. PEMDAS. So I see my green parentheses. I can't really do anything. I don't really want to square this. Okay? So I'm going to leave that. I can't do anything inside my parentheses. So I'm going to not write the parentheses. Okay. Now, radicals are like parentheses. So, is there anything I can do inside? Yeah. Minus 2 plus 2. Okay. I am trying to do my PEMDAS in order. Okay. Exponents. Do I have any exponents I can simplify? Yeah, I'm pretty sure those things are perfect squares inside the radical. So E is for exponents, which are radicals. And so this is going to turn into 1/2 minus 3 still there. Now you could, right, you got 3 things to multiply together. Just pick 2 at a time. I'm going to pick the first 2 because they get 1. Then I'm going to multiply, distribute. There's no divide. Add, subtract. X. Now, you really should do both directions. Try the other direction. Right, as practice, try the other direction to see if you can get through the steps, and you should get yes. Okay? Yes means like, yeah, look, F composed of G actually does equal X. I should have taken up less space here. Okay. So this time let's put G on the outside. Okay, there's my setup. Right, I tried to put the inside function in a different color so you can see the substitution.
Wait, so how do you know what to put in?
Given the definitions that you start with. So here's my f and my g. Those are the two functions that I'm composing. Okay? So
Oh yeah, this makes sense.
so here we go. I'll highlight. This one is going in to g. So you're replacing the x with whatever you're substituting. And then on the other one, this one was going in to f. All right, let's see what we get. PEMDAS, start inside the parentheses. So the -3 and +3 go. Okay, okay, I don't have anything to do inside the parentheses, so now I'm going to do the exponent. I'm going to square.
Did you have the -3 + 3?
Yeah, I just did it. Okay. So there's the square. Now I keep the other portions. So I have 3 things to multiply. Pick 2 at a time. Why not? Let's do this. 4x + 8. Doesn't matter which 2 you multiply, just 2 at a time. Now I'm going to distribute. X. Good. That's what you're supposed to get. Okay, so left 4, up 3. 1, 2, 3, 4, up 3. With a stretch of -2. So that's over 1, down 2. Over 4, down 4. Over 5, 6, 7, 8, 9, down 6. 1, 2, 3, 4, 5, 6. Okay, so here are my points. Now I'm going to do it graphically because why not? Right here. So +3, -4. 1, 2, 3, 1, 2, 3, 4. +1, 3. Okay. 0, -1, -1, 0. 1, 2, 3, 4, 5. So -3, 1, 2, 3, 4, 5. Okay. In order. Starting dot. Alright, so it looks as though I have the left side of the parabola. Now, if I am looking at my diagonal line, now the graph isn't exactly square, it's a little stretched. Notice that y = x, they actually intersect. They intersect on the line that they reflect over. Okay. Domain of the original. So I'm going blue here. That's -4 to +infinity. Ooh, the arrow's on the bottom. -infinity comes first. Negatives to positive. positive 3. Which means I could just switch this, because that's... Alright. And composition. So let's start with... I'm going to start with this composition. Okay. With the inverse. There we go. Let's see what I get. Okay, so we have 1/4 negative 2 root. Okay. Minus 3 squared minus 4. Okay, so my plus 3 and my minus 3 cancel out. Okay, and then I square. And I multiply. And then I get x. Okay, so that direction works. Now, I do realize that some of us came into an issue with a negative, so we're going to work it out. We're going to see what happens. So now I'm going to compose the other direction. So negative 2 root 1/4 x. I actually do know why this isn't going to work, but it does. It's just a little tricky to explain. Plus 4 plus 3. Okay. Three. So we end up with negative 1. Okay. All right, there's only 2 minutes left. I do have the answer for this. I'm not going to say it in 2 minutes. I will explain it next class, okay?